Are we live? Hello? Can you hear me? Why is my mic so high? Hello? There we go. That's better. My little brother-in-law was using my desk to edit some of my videos, actually. I'm putting them to work. $2 per job. It's not child labor, it's family, bro. Come on in. Let me know if you can hear me in the comments. Let me know if you can see me okay. Today's episode is going to be so fun because we have one of the leading AI experts in the Tesla community joining us today. Do you know who he is? Can you tell by the thumbnail by any chance? I wonder. But before we introduce our special guest, we're going to introduce our two panelists for today. We're going to have Ishan joining us. Hello, Ishan. And Hans in a car, but soon to be at his house. So there's some novelty factor for y'all. And then our very special guest, the one, the only, James Douma. Thank you so much for joining us, my friend. Appreciate you having me. Yeah, I appreciate you coming on with us. All right. So for those that are not familiar with these live streams, these are going to be very conversational. These are just meant to be places where we can sit down and really explore topics in depth. And James, being an AI expert and really understanding the Tesla story, we're going to spend quite a bit of time around those topics, obviously. But we don't know where the conversation is going to go. So sit with us and we'll see where it takes us. So I guess to get started, James, thank you so much for sharing the look, Hans already dropped out. I love it. Great start. One of the things that I saw from you yesterday, which I really appreciate, was you were sharing the conversation we had on this channel a couple of days ago with Bradford and Scott and John, Dr. Know-It-All, about the bot. So I really appreciate you sharing that. But I'm curious, did you have any thoughts that you wanted to share from that conversation? Was there anything that stood out from a topic perspective that you'd like to share, just to kind of maybe get some thoughts to get the conversation started? Let me go from there.
I was really happy with the quality of that conversation. I actually don't talk to lay audience. I mean, outside of my family, I don't talk to lay audiences about this stuff very often. And everything you see in newspapers is so cringeworthy and so completely racked with misconceptions and whatnot that, I end up being a little apprehensive about trying to tackle this. So being able to come up with the right way to explain something that on the one hand isn't going to mislead someone who's not familiar with the topic, but on the other hand isn't going to get me a lot of hate mail from people in the field, right, about the details that you got wrong. And seeing the four of you, because I felt like you clearly got it, right? The sense of what's going on, that a lot of the conversation surrounding this topic loses important nuance. Like when you talk about whether something's going to happen, like time frame is so important. And you guys clearly understand, it's not neither Tesla bot nor AGI nor any of those other things are like a binary thing where like it's there one day and the day before it wasn't there. This is, it's an arc. And what things look like in 2 years, 10 years, 20 years is different. And then this is the social dynamics of the introduction of these incredibly disruptive technologies is another topic that's you read about it in the lay press, and it's hyperbolic and gloom and doom, and it it's going to be manageable. And I thought that the panel that you had a very realistic and expectations for how it ought to go. So yeah, that's why I thought it was such a great discussion. I mean, there's four people, four really different perspectives. You had a good back and forth on the topics, and yet it was all basically on the mark, I thought, and it was good.
Awesome, man. I really appreciate that. Thank you. Yeah, one of the reasons I even wanted to have the discussion was so Bradford hosted a Twitter space on Saturday about the implication of the bots to jobs in the long term, short term, so on and so forth. And like you, like I am the farthest person away from an AI expert. Like I am about as lay gets with that topic. Let me go this way. That's a little bit better. But the one thing that is missing right now is that it does appear like we're moving towards a time in technology and in culture almost like that this sort of thing is really starting to gain traction, and Tesla being one of those first companies that's starting to drive that technology to the public, right? Like neural nets and AI that's narrow, that's very useful, like FSD, but then it's going to get more and more complex over time. But I see, to your point, no conversations that are geared to the layman, like myself that actually describe what is actually happening. Like it's missing from the conversation big time. And I almost go back to the age of the internet, like back when it first came out, I don't know, like 80s or 90s, where there was this, I remember going on YouTube recently and watching all these interviews. What is the internet? It's just, it's nobody had any idea what was going on. And then 10 years later, the world is a completely different place. Is that how you think about it from your perspective? I'm curious to kind of hear your thought process as far as like 10 years from now. How are you seeing this sort of thing developing? Do you think there needs to be better conversations in the public discourse to try and bring more awareness to the pros and cons of this thing? I'm kind of curious to get your take on that a little bit.
I think the public actually does pretty well with these. We're not, technological disruptions are not a new thing. Like the last century, 200 years has been just completely racked with life for everybody has changed radically in the last 150 years. And we absorbed it. And so we've got all these historical precedents we can look back at to get an idea of how society adapts to these changes. And my sense is that people do okay. But the narrative, like if you're going to fearmonger, if your focus on change is what's the worst thing that can happen, and let's spend a lot of time talking about that, and you can do it constructively. Like let's spend a lot of time talking about it so that we can avoid it. Like you can have the best of intentions, and you still end up kind of missing, the forest for the trees, right? You end up focusing on some narrow aspect of the problem, like when you were talking about people, just jobs getting displaced, like a natural thing to do is you think about, well, like a humanoid robot, all of a sudden it can do manual labor jobs. So you imagine somebody with and your common sense keeps you focused on like that first person who's affected, because something they used to do is now being partially automated. So, the simplest approximation to that, to like what the consequence of that is, well, that person there'll be fewer of those people working. But, a great example of a disruptive technology is the spreadsheet. When the spreadsheet got invented, prior to the spreadsheet, you used, if you worked with numbers, you had an adding machine and you had pencil and paper, right? And a spreadsheet it made people who did those things fantastically more productive. But what happened is like the world did not get fewer accountants. Like people the adding machines went away, but the spreadsheet showed up, and the response of industry to this was to raise their expectations. It didn't. Now that with spreadsheets, now what we expect somebody who works with numbers to produce has gone up dramatically. But then the value of the product that they produce also expands really dramatically. And then the demand for that product goes up because the economic utility of it has expanded a lot. So you have to kind of step back from the immediate local effect of just thinking of just that job in just that context, because the rest of the system responds too. The price point for that service changes, and the demand for that service frequently goes up. It's the invention of the loom. It's you go back 100 years, 150 years, people had one set of clothes that they wore. You might have two, so that you could have one washed and one didn't. You had one pair of pants. You had maybe 2 or 3 shirts, right? Because clothes were really expensive. It was a major outlay, which is why, when people died, you didn't bury them in nice clothes. Somebody inherited their clothes. I mean, it's almost inconceivable now because the invention of the loom, it took clothing and cloth from something that was, an expensive thing that you had to plan your life around the scarcity of, and it made it completely ubiquitous. Like a t-shirt today, the manufacturing cost of a t-shirt is less than 25 cents. So they're like free. And that people did not respond by like the number of, sure, the people operating looms might have gone down slightly, but the demand for clothing exploded. Now we all have, closets full of clothing, and the homeless people in San Francisco can go down to Goodwill and get better clothes than you could buy 100 years ago because there's so many clothes, we just give it away. So more people are in that business now than were in that business back then. The whole economy has gotten better. Like there's more money, there's more free time. And then what was it? Scott came up, he mentioned, you go back 100, 150 years, 98% of people were farmers. Okay. Well, okay. What are those 98% of people doing now? And the answer is everything, right? Everything. And if you'd gone back and you'd talk to people who were working on the farm at the time and saying, oh yeah, we're going to get a tractor and you and the horse, you're going to be out of a job. Okay. And if that guy thinks, oh, what am I going to do? I'm going to get a PhD in machine learning, or, the people who are working on the farm, that's the life that they know. That's not what they immediately imagine, right? But opportunities open up, and that, there's transition takes time. People are always worried about these, and they always work out great for us in the long run. And so even though I can't paint you a picture of exactly what it means to any individual person, the historical precedent is that technological disruptions are really good for people, 10 years down the road, 20 years down the road.
Gotcha. Ishan, I saw you went off mute. Go for it.
Right. So this is actually a great segue for this question that I had. And as the Tesla bot, starts getting created, has some very basic skills, potentially has been used in the gigafactories, etc. Do you see an opportunity or an ecosystem of skills being developed by third parties? For example, would you and I get together, create a company that sort of creates this couple of specialized skills on top of the Tesla bot and then deploys it in a specific scenario? For example, let's say elder care, or security, or some other thing. And maybe Farzad and Hans get together, create a company, and create a different set of skills and deploy it on top of learning a little bit from what's happened with Alexa, learning a little bit from all the entire app ecosystem that we have on our phones now, hopefully on Teslas as well at some point. So do you see this like the world moving towards this sort of an economy at some point?
I think a lot of that, there will be lots of opportunities in programming robots, handling robots, managing robots. I mean, one job that I think is going to show up really quickly is so the advantage of a Tesla bot style humanoid robot, I mean, if they go in the direction that I think they're probably going, I mean, the reason you do a humanoid robot is because it's general and it's flexible. So in order to make it general, flexible, and easy to use at the software end, you want something where you can demonstrate a task, or you can give simple verbal instructions to it, and it can do its job, which is different. I mean, industrial robots right now, they have all of these specialties that service them, but they're very different kinds of specialties, and they're much more technical. If Tesla succeeds at making a Tesla bot that's on the track to being generally usable, like something that at the end of its arc of development is something that people can have in their home, that you could trust to take care of your mom or watch your kids, right? On the arc to going there, one of the first things you want to do is make using and instructing it relatively simple. So there will be some people who are sitting down at computers and writing programs and stuff that will go into Tesla bots. But I think there will be a much larger number of people who will have, you'll be the guy in the factory and you've got 10 Tesla bots, and your job is, if they're feeding the robots in the cage, factories aren't static. They constantly evolve, especially as Tesla's factories. They evolve really rapidly. You switch out your products, you improve your processes, you make changes and that kind of stuff. So there's going to be a constant need. And if you have Tesla bot style robots, dynamic, easy to program, flexible human robots, that's going to be the point team when you make changes. Just like right now, the point team is humans. You make a change on your production line, the first thing that you do is the people change, right? And then once the people have that, then you start to automate those things. But automation is brittle compared to people. So the first thing that changes, and the thing you change the most often, the most frequently, is the people in the factory. And the Tesla bot will, it'll be the second tier of that. It won't be as flexible as a human being, but it'll be way more flexible than an industrial robot. So, every 10 Tesla bots are going to need a human being to do the care and feeding of the Tesla bots, right? To show them the task, to make sure that they're doing it right, to update their task when things inside the factory change. So, you'll be a platoon leader for a platoon, and like that'll be a really interesting job to see pop up. And it's not a job where Tesla's only going to need like 5 of those guys. If Tesla's got 3,000 robots, then they're going to need 500 people who are platoon leaders for teams of robots. So, but you'll see the whole hierarchy of stuff, just like with computers, right? There's people who work in assembly code, people who program GPUs, and there are people who just do, JavaScript for websites at the other extreme. Or, you use your Google spreadsheet to, to solve a problem or build a model or something like that. You're also programming, you're also using a computer, but you're just at a totally different level of stack. Some people will be building tools for other people. You'll have all these layers, and it'll be a big enterprise, and there will be a lot of people involved in it.
That's a very interesting sort of rabbit hole that we're going down. And Eric, maybe alongside this conversation, asks, would it be a good move to open source the bot instruction code as well? How do you guys think about that? Or James, how do you think about that?
I'm sure what layer are we talking about again? At the assembly, at the driver, at the operating system, you might have one answer. At the top end, the instruction code is, hey bot, it's verbal instructions, or it's like, here, I want you to do this, and you demonstrate a task, and then it tries it in, and managing bots in the near term until they're really good, we're probably 10 years away or more than that, is going to be like, managing kids in a kindergarten or something. You're going to be trying to instruct and get cooperation out of these, not quite human, not fully capable systems that when you have experience, you'll learn, well, if I demonstrate it to the robot this way, it'll learn it faster than if I demonstrate it that way. Or, how to, just like, when you talk, if you dictate text messages to your phone, you learn a certain manner of speaking. There will be a manner of dealing with the robots, and people will become proficient at it. It'll be a skill. So I mean, that stuff is as open source as it could be. You shoot a YouTube video of you instructing your bot, and you've just open sourced the code at the top end of the stack. Down the stack, there will be people who will want to keep it proprietary in various industries because they'll have stuff they want to protect, and for security reasons too. And one of the things about the bots, not at the lowest level, not at the highest level, but there will be intermediate levels where you want to keep a lid on changes that can be made, just like we do with computers that access the internet today. We exercise a lot of control over certain layers of the stack to keep the system secure overall. And, so everybody is protected, and we can, you can enter your credit card into your web browser, and it's not going to be used in North Korea next week to buy stuff. So, similarly, there will be layers that you're not going to want to open source. At least you're not, it's an interesting thing. SSH is open source. SSH is an incredibly important tool that we use for, the code for how the certificate exchange in web browsers, it's open source. You can inspect it, right? But that doesn't necessarily mean it's open in the sense that anybody can modify it anywhere, right? You have to exercise a certain amount of control in order to be able to guarantee a certain level of service to non-technical ultimate users, right? So not everything will be open, but I think most of it will be.
Makes sense. Ishan, go ahead.
No,
I'm curious. Yeah, technically, in the maybe short to medium term, what does it look like to train? Like, what does the Tesla bot learning new skills actually look like? Building out models that are probably sitting on top of foundation models, or what does all of the actual technical nitty gritty look like there?
Yeah, so that's a moving target too. So what it looks like on day one and what the robot can do on day one will be really different. The better the robots get, the easier it will be to interact with them, the more forgiving it'll be. In the short run,
well, to make it more exact, maybe we say at the point that Tesla bots are first being shipped to customers outside of Tesla.
I think a lot of the early process ends up looking a lot like FSD, where and with the exception, like there isn't a layer on top of FSD that we let people program. And there will be a layer on top of the bot that we let people program. But there will be a lot of the hard work is going to be building the foundational technology. I mean, like users are rarely going to need to modify the way their robot walks, but you want it to be able to walk, and you want it to be able to go upstairs. You want it to be able to walk up a ramp, walk across the yard. So like all that stuff has to be done. And on day one, it might be, it's not so good with steps and it's not so good with sand, right? Or you don't want it walking in a gravelly, parking lot or something like that. And, it'll get over that stuff and it'll get better. It's an interesting question, like what level of sort of locomotion function do you have to get to before you can put it out in a factory? If everything is a flat concrete floor and the only thing you have to worry about is not hitting a wall, that's a pretty low bar. You can probably do that pretty soon. You might have to get a lot higher before you turn it loose in the world or you let it operate in other people's factories. But of course, the goal in the long run is to take advantage of how the flexibility of this thing. I think it's going to be pretty clunky starting out. Humanoid robots are pretty clunky in the world, especially because our instinct as a human being is to evaluate a humanoid robot against humans. And humans are amazing. We're incredibly capable. So every robot is going to look really bad for quite a long time to people, but I think they'll be quite functional within a restricted domain.
Yeah. Are you surprised by the progress that Tesla has made so far to have a robot ready to be shown, we hope, this year? Or were you like, how do you think about that first step? Is it within the realm of, like, if you're going back a year ago when this thing was first talked about, did you envision something being shown as early as this year, or did you see it being later on? Like, how did you think about that?
It's going to completely depend on how they show. They could impress us. And there are labs out there doing, Locomotion, for example, with neural networks, not so much on bipeds. There's a lot more work done on the quadrupeds because most of the labs doing this don't have a ton of money. And that's a much less expensive and less risky platform to work on. Locomotion is pretty close to being solved. In fact, you could argue it's solved within certain constraints. Like there are approaches that are known to work. You could apply them in the bot. Maybe Tesla will adopt one of those. Maybe Tesla will decide that they don't want to, and Locomotion will be clunkier in the short run because in the long run they have goals that they want to get to that are architecturally incompatible with the existing with the approaches that actually work well today. And one of the things I expect to learn is, like, what's their focus? Because it's a big problem. Like the humanoid robot problem is much bigger than the FSD problem. There are a ton of things that you just don't need in an FSD car. They're going to have to work in the robot, and they're going to have to be pretty good. And Tesla could decide not to do that stuff in the beginning. They could, with Starship, it was like, let's build a Starship factory. We're going to make tens of thousands of rockets, and we're going to get better along the way. So the first ones will be clunky, but the process is important. So if part of what Tesla wants to do is to build a robot factory and learn to make robots and that kind of stuff, then they might go out the gate really quickly with something that's relatively low functionality, but gets them something. And then they could decide they're going to throw that away and start over again in a year or 2 years or 3 years. Or it could be that their plan will be, no, we want everything we do to be on a straight line to our ultimate goal, and they know where they want to go. And, and those paths will look different in the early rounds of what comes out. And so when we see their first couple of products, when we see their first product, we'll start to get a sense of like, what is the path that they think is the right way to go through this? And I think there are a lot of viable approaches that you could take. Or certainly there are a lot of different approaches that if you were putting together this effort and making a pitch to somebody to do this development, there are a lot of different approaches that you could take. And they might do more than one. Sometimes you want to do more than one. So that's something that I'm actually more interested in what we learn about their development process than I am about the details of whatever the first product is, because the second product, the third product, it's going to change. So it's going to change faster than FSD did. It's going to change really fast. And the first talk I heard from Andre that was really interesting was when he talked about how they did the internal development of FSD. like the data engine, like that was brilliant. The way that they broke the thing up, this idea that, we're going to have a team and they're going to make the neural networks, and we're going to have this other team and they're going to consume the tools made by the main team, and they're just going to turn the crank. This is the thing that we need, like the data, and I thought that was incredibly clever. The way they do training, like Andre talked a couple of times about how, because not just FSD is an unbelievably huge and complicated neural network model. So how do you break that down into modules? So you can give a part to this guy and a part to that guy, and they can both make progress on their own. They don't have to be super tightly coordinated. When you rebuild the system, how do you rebuild just one part so you can iterate on a subset to work out a bug and then integrate that back into the whole thing? These were all totally unsolved problems. Like nobody really even thought about how to do this. And Andre came out and he talked about how they were doing that. And on the one hand, you could say, well, it's not like E equals MC squared. It's not some like quantum leap forward that nobody thought of. It was one of many things that people might have thought would work, but they had it working, right? They had a team of like 50 or 100 people. They were iterating a product. They were shipping every week, every 2 weeks, updates on these things. And then to me, that was like an incredible gift to the machine learning community, to the industry, right? It's like, this might not be the best way to do it. We're not saying it's the best possible way. There might be other better ways, but this way works. Like you could just adopt this process for your whatever you're going to make for your AI in the real world thing, and you could do it. So, they have, an organization and a process that they understand, and it kind of would make sense for them to sort of adopt that as their first cut for how they approach. So I'm expecting to see a similar team developing neural networks for perception. They have to add neural networks for locomotion. I think neural networks for locomotion in the long run is really important to enable. That is, there's a ton of feedback that a robot body is a lot more complicated than a car. Like, if you turn off the control system for a car, it doesn't fall over on its side, right? There are a lot of things there's just so many more degrees of freedom and so many more potential surfaces and whatnot that you have to deal with. You really want to take the intelligence that you have, that a neural network makes available, and you want to apply that to the problem. Now, a lot of robots today, they're done with conventional motion control. Like, I don't know if this is still true, but famously Boston Dynamics, they use conventional, control systems for doing that, but they're really limited. You're just not going to get you're not going to extract the potential of that humanoid robot body if you restrict yourself to those kinds of things. But then on day one, you're just trying to get a demo working, or you don't want to worry about locomotion. You want to worry about pick and place. Maybe you bolt that in. I would kind of be disappointed if they did that. Like I really want to see them just do the neural network end to end and work out the kinks as they go. And that's a thing that we'll learn. I mean, experts in the field, like you can look at the robot and you can tell if it's running a neural network or if it's running PID code. Like people you've watched a few videos of the robots that locomote with neural networks and the robots that run on regular code, it's obvious just looking at them which one it is. So maybe we'll get to see that.
So a lot of people have this idea that whatever they unveil on AI Day is going to be pretty close to the final, at least first iteration of the product, because that's been historically something that Tesla does with their cars. But so are you in a camp that kind of agrees with that? Or would you think that it's maybe more in line with like Neuralink presentations or those types of things where it's much earlier in the development? We're just kind of getting the flywheel going, dipping our toes in the water of going down just a completely new and uncharted path?
So the work I've done looking at the mechanics of building a mass-produced robot suggests to me that the place that you want to go is not a place that you can start out. Sorry, my idiot meter is kicking in. The CO2 level in the office is up. So I think that the core technology that's going to go into building most of the elements of the robot body, including the hands. The hands are super hard to do. like it might be that you can't even do a rough prototype of those for a couple of years because you have to build this foundational stuff. So you have to start with something. And so I guess the question is, a question might be in that situation. Well, do I want to start with something that's kind of functionally equivalent, but say expensive or hard to make, or maybe it doesn't have as many degrees of freedom, or maybe it moves more slowly than I would like it to. And in the short run, I'll deal with that. Or do I do something clunkier? Like I'm going to have the hand team go work on the hand, and they're going to take that offline for a year or two and try to figure out how to make a really good. And in the meantime, we're going to have some stupid gripper or whatever on the robot. Like that's another thing that you could do. Tesla's presentations, they're this mix of marketing pizzazz and technical demonstration. And in this case, it's a recruiting event, which makes it even more opaque. And like I could see it going either way. Depending on what you're prioritizing. Like, do we want to really wow the audience outside the room? Do we really want to wow the audience inside the room? Like, what message do they want to send? Or alternately, maybe they don't want to send a message. Maybe they're in the PR is for schmucks, thing that they often seem like they are. I don't think they really are, but they often seem like they are. And they're just like, hey, we're going to show you a little of what we're developing, and we're just, I don't think the Starship, I don't think they made it look that way for marketing, but it worked great for marketing. Right? And the marketing on Starship worked out great. But you can imagine, like, Neuralink is the opposite end of the thing. Like, very few people want to see the intermediate stages of Neuralink because the biology and surgery and all that kind of stuff is kind of cringeworthy, right? So maybe they hide that. And which one would the robot be? Do you want the robot to be super pizzazzy? Is that something you want to go for? Or do you just want to be super nuts and bolts? Because you want people to really believe, that you have a clue, that you're not smoke and mirrors, right? You're going to do it for real. It's hard.
You certainly don't have to build it out in the middle of nowhere with open buildings where everyone can take pictures with.
It would be kind of cool if they did.
It would be. All four of us would nerd out and go there and take some pictures.
With the giant camera out in the
I'm sure
parking
we'll
lot.
have insiders. So speaking of
go ahead, Ishan.
Sorry, go ahead, Farzad.
Well, just a quick one. It's just so maybe because I'm curious, like from a technical aspect, I'm wondering if Tesla will show something that may surprise you, James, but like I'll be like, I don't know what the hell this is. Like, what would be something that would surprise you for the positive in AI Day 2 that maybe the layman wouldn't understand? Like, what would make you really go like, holy crap, I wasn't aware they're this far along, that it's completely like the rest of us would be like, oh, cool, pretty colors and numbers. Like, what do you think?
Well, I've said
Sorry
before,
for putting you on the spot.
There's so many things. There's so many things that are really hard in robotics because we're used to human beings and because we judge robots against humans, which are just incredible and in their physicality and dexterity and grace, that a lot of things that would be underwhelming if you evaluated them, like, picking up something slippery. Pick up a cat. That was an example. Like if you picked up a kitten, like if you could pick up a kitten without hurting the kitten, without freaking out the kitten, so that the kitten cooperated and that kind of stuff, hold it and pet it, right? I think that's the kind of thing that to a lay audience, I mean, they'd love it. Oh, it's so cute and that kind of stuff. But the people in the control world, their heads would explode because that is so far off the over the horizon right now. So that's an example of something that you could do. And maybe you would do it as a gimmick. Like if you thought you could pull it off, maybe you would do that because, it would really wow the audience that you care about. But there are way simpler things than that. Just, I think the example of, walking up on stage and shaking someone's hand, just walking gracefully. Like if you can walk with a human-like gait, like humanoid robots can't do that right now. You walk with a human-like gait. So what was it? I think I was talking to John, Dr. Know-It-All yesterday, and we were fantasizing about, put pants on it, give it a trench coat, and have it walk up on stage. Because if it got up on stage and took the hat off, and you thought it was a robot, that would slay people, experts in the field. But to people whose understanding of robots is what they see on the big screen, right? They're not going to be impressed. But the experts would just lose it over that.
Yeah. Got it.
And I got one for you, Farzad, and it's a great segue into the question I was about to ask.
Okay.
What if they showed skin? And imagine this. I mean, it's probably one of the hardest things to do. But if you look at what Elon's ecosystem already has, and you pick up something like Neuralink, they've already figured out how to connect with a bundle of nerves, which means they already have microwiring figured out, right? What if they just put, let's say, a suite of sensors, one heat sensor, a pressure sensor, and a bunch of others, in a small 1 millimeter, I don't know, tile, and tessellated it on some kind of a resin. Used, something from Neuralink to actually bring all of that back into probably, let's say, you've got one chip for the arm, and you've got skin around potentially the fingertips at certain places that probably not the entire thing to begin with, but if this does get demonstrated, and to your point, that'll really help lift that cat, and it's a mind-boggling problem as of today. So
Skin is hard.
you know,
Yeah, it's
it's hard.
when we saw looking at what Tesla was doing in the neural networks through autopilot, like the first versions were just like cut and paste copies from academic papers, right? And I remember saying to Dave Lee on I think the first conversation we ever had, I was kind of disappointed, right? I was expecting to see, some more insight. But later I thought about it and I thought, no, there's so many things you don't know how to do starting out. So so the things you can take off the shelf to get you going, take those. And you don't want to mess around with any weird architectures or anything, because it's hard enough, like, figuring out your data pipeline. How are we going to get all the labelers, and just recruiting labelers and writing the labeling tools, and like getting your, your training apparatus, or you've got to do all this stuff at the same time, right? And then but what did happen, what I was very pleased to see, is that around the time they got into FSD, they started really bringing in novel stuff that I had never seen anywhere else. Like they had new approaches to, and it kind of, it makes sense in a couple of ways. They, and you could think you could kind of think of it as like they had gone as far as they could by just like copy pasting other people's stuff and making, changing the hyperparameters or whatever for it. Because they started out with this inception based network, and then they started fiddling around the edges, but it was mostly straightforward extrapolation of the idea behind the inception vision network that they started with. And then later they started really getting much further afield. Most of the stuff is still based on techniques that somebody else proves out, but they're building their own architectures and stuff, right? And now, some of the components of the things that we see them doing in planning do actually seem like they're totally novel and innovative, like internally invented kind of stuff. So to me, skin feels like it's the kind of thing that you get at that level, right? So you have a couple of generations of you, because you don't skin, you get a lot of stuff from skin. Like it would be really great to have, a tactile membrane that was pressure sensitive, that you could spread over a lot of the surface of the robots. There's definitely a lot of utility there, but it's not going to add a lot of functionality until you've got much more basic problems solved, right? It's farther down the list. So like if they had a team in-house working on skin, on an artificial skin, like that would be great. I wouldn't expect them to talk about it right now because it'd be way too subjective. And it's the kind of problem where you can look at it and you can say, well, there's like 50 different ways we got to do it. And we're going to spin up 10 teams that are going to look at 10 different ways. And it's hard to explain to a lay audience, right?
True.
So,
But my question was more around like, would something like this, would you see a lot more multidisciplinary recruitment efforts, and just the team, right? Not just AI and software focused, but also a lot more like, folks from biology, biophysics, from other areas of expertise sort of coming in to build the Tesla bot, and not just, mechanical engineers and electrical engineers and AI folks, etc., getting together. But we would traditionally feel like, is biomimicry something that you would see in the recruitment efforts itself?
probably, I mean, if they were doing it now, that would be really impressive. It would be, they're very ambitious. They're, I think you will see a lot of disciplines that aren't just, software and hardware engineers, because there's this materials science thing that I keep talking about the actuators. Like, the actuators are a really big deal. Coming up with a really good actuator, like, there just isn't anything which is ideal for a robot. And if we're going to make hundreds of millions of these things, like, it's going to get very optimized, and somewhere along that path you really want to figure the actuator out, and that's going to take a lot of specialty, which isn't just electronics and neural networks. So, but biology, I think human factors is going to be something you're going to see them do a lot of recruiting on, because figuring out the user interface, like how to get robots to interact cooperatively with people, how to make them easy to train. Like, there's a significant amount of novel territory to cover there. And you might want psychologists to, like people that you normally wouldn't sort of associate with a hardware engineering project in there.
Well, I didn't even think about that angle. There was a comment someone made. I forget who made it on the Monday, but you're talking about like the human relationship. What if the bot sort of shows up and then it sees the crowds of people and just like freaks out. It doesn't know how to handle the situation of being surrounded by humans, and it has like a bot stage fright moment, So it's like all these different sort of variables that become, they're so abstract for me to think about today. But I think sort of to the point of the panel is like, as we go through the development process, like all these adjacent fields that the skin thing, I've never thought about that. And Ishan bringing it up, I'm like, holy shit, that makes a lot of sense. Being able to feel what you're touching, like that's unintuitive for me. Like it's a bot, it's going to know how to do that, but like, okay, but how? If it doesn't have the sensors or the connection to the brain, and it doesn't know how to interpret that data set that's coming through the fingertips, how is it going to know to do that, right? So, and it's like the complexity of being a human. Like, it's almost like we're seeing just how complex, to your point, like how complex people actually are. Like, if we break it down to the nuts and bolts, holy shit, humans have a lot going on. Like a lot is happening up here that's processing all the information that's happening in real time. And I don't know, like, I'm curious if there's going to be any other company that's like, I wonder how many things are going to come up adjacent to Tesla as we go into this robotic age that's going to help maybe the broader population understand just how, I don't know, how unique we are and how difficult of a problem it is, and how game-changing of a technology this actually is to replicate or try to help us move forward together as sort of like a species with some help. I don't know, like that thought just came to my mind, and I don't know if anybody wants to like sort of riff off of that, but it's going to be interesting to watch. It's going to be really interesting to watch.
Yeah, there's one really interesting question that kind of builds on that you touched on in your interview with John, and that is like, how critical is really good proprioception for actually creating a good first functional prototype?
Hans, help us understand what that really big word you just said is.
James will handle it. Yeah.
Proprioception is it's internal feedback that your body is telling you about the joint position and the tension on your muscles and joints. So here's an interesting observation. Human beings, like, people who suffer from neuropathy, often their proprioceptive systems become impaired and they lose the ability to walk. Now, they can still feel. They still have pressure sensors on their feet that they can feel. They still have their sense of balance. It's still okay. But walking becomes really hard for them to do that. And this is a human being, right? Humans, they have very sophisticated control systems. Somebody who might have known how to walk well their whole life. But once their proprioceptive sensors start to degrade, they have a lot of difficulty getting around. I think that's a clue about how important proprioception is. We build robots mostly without it today. In fact, one of the first problems that I was really interested in looking at when I saw ETH Zurich does these really great totally neural network training, sim to real robot work. And I've always been really interested in the whole proprioception thing. This last year, they came out with a paper where they demonstrated they have a, they work with these spot type robots, and they demonstrated, because one of the challenges with proprioception is vision is a really useful tool. And incidentally, human beings, we use both vision and proprioception to maintain our balance and stride when we walk. It's if you tilt your head back and you try to walk, or if you close your eyes and you try to walk, even if you're in a completely open space, your gait is much less sure if you close your eyes, because your brain uses the horizon level and the motion of things in the environment to judge your, how your body is moving in conjunction with your semicircular canals and your balance mechanisms and that. And it's also using the feedback from the amount of tension in your muscles and the joint angles as you're moving around. It uses all of this stuff. And degradation in any of these things has a significant impact in people's ability to locomote well. But most of the locomoting robots we build lack one or more of these sense modalities. So really interesting question to ask. And one of the reasons we haven't traditionally put these sense modalities in is because if you're not using a neural network, because remember, a neural network is this unknown black box, and I stuff a bunch of inputs in and I say, this is the behavior, now train, right? So the more inputs I put in, like if I put an input into a neural network and it's not useful, the neural network will just ignore it. There's no downside to hooking it up. So with a robot, like to a first approximation, you give it tons of sensors, you wire everything up to the neural network, and you let it see what it can make use of, right? And so a thing that you can do at the end of that is you can go back, like once the robot's actually pretty good, or the neural network has learned its job, you can go back and say, now what did it find a good use for, right? Because probably the sensors that it's just ignoring, those are the ones you don't need. And then on the other ones, you can look at how big an impact they have on how good the robot is at doing different kinds of things. And you can get a sense of, oh, we better put this sensor in. We don't know why, but this one's really important. It's really using it a lot, kind of thing. Like, I thought that would be a really interesting study to do. But because it's a thing we haven't done with robots. We've dumbed robots down because we have these very simple physics-based models that we use, and these very simple control models that we've used. And so proprioception hasn't been on the list because it's hard to know how to use it, right? If you have to write the program. But if you feed it into a neural network, now the sky's the limit, right? You can toss, maybe temperature matters, it's, there's all kinds of stuff that might not occur to you that could turn out to be important and useful. And so yeah, I expect them to use that stuff. I expect them to toss it in. And I would say the evidence from animals is that proprioception is really important and it's really useful. Anyway, so the ETH guys, they have proprioception in their robot, and they also have a vision system in their robot. And one of the problems that they were struggling with up until recently, and that they finally figured out how to do last year, was how do you balance between those two? And because they would have these, like, they would have the robot walking in grass where it couldn't see the ground. And when it couldn't see the ground, the balance between, like, how much do you feel your way through, or when it's walking through snow, like they have this great video of their robot, it's walking in, knee deep snow essentially. So it can't see the ground at that point. And it doesn't really have a good horizon either. So it has to rely more on proprioception in that kind of situation. Mm-hmm. But for instance, if you want to move fast in an environment, which is like, say, stairs or obstacles, you're very vision dependent. So then you want vision to matter a lot. So how do you use both of those and not be using the wrong one in the wrong situation? And they found a way for the robot to train itself to figure out that balance in a variety of different terrains.
Right. So proprioception is really the biological equivalent of perhaps sensor fusion, right? And with FSD, what Tesla sort of arrived at is that we're probably not at a place where sensor fusion is done very well, or even we probably have the wrong set of sensors that we are trying to fuse.
The sensor fusion problem between radar and vision, they have an IMU, and I think they're probably still doing sensor fusion with the IMU. It doesn't have the same sort of collision with vision that radar does. With radar and vision, it's very tempting to have situations where one is impaired and you want to rely on the other. And if you're in a situation, I have the example of the back end of a truck, a fire engine. Fire engine's classic. You got a fire engine parked to the side of the road, butt of the fire engine is very slightly sticking out into the road, and your camera sees this weird vehicle that it doesn't see a lot, and it's parked in a place it rarely sees vehicles parked, and it's a weird shape, and it's got this part that's kind of sticking out, and your vision system looks at that and says, is that in the road? I'm not sure if that's in the road. And the radar system, because the fire truck's not moving, says there's nothing there, right? And it's just the nightmare scenario where figuring out the right way heuristically to balance between those two is tough. And trying to train a neural network to do it is hard because you get so few examples, so few real world examples of that to train against. And in the end, Tesla kind of found, yeah, maybe we don't need the radar because but forcing the vision system to get better at doing that rather than letting it use radar as it's a crutch that breaks sometimes, right? And so when your crutch breaks and you're relying on your crutch, that's bad.
Yeah. And then we bring it to the, sorry.
Go ahead, Ishan.
Oh, yeah, go ahead.
Okay. Yeah, no, so I was just asking, when we bring this over to the Tesla bot and we are trying to solve for proprioception, and we are essentially, it's probably not just going to be vision. It'll probably be a bunch of internal sensors, there'll be pressure sensors, a bunch of others as well. So do you see this being one of the key, I would say, step goals to achieve good sensor fusion for the entire project, to get to a level where there's confidence in taking it out to the wild? Before this, confidence in the Tesla bot will not be there, even for the internal team.
That'll depend on the sensors that they go with. My expectation is they'll use vision, they'll use balance, and they'll use proprioception as the primary components of doing locomotion, and that fusing those is going to be important. And I expect them to do it. And I think fusing those actually isn't too tough. Now, if they do what a lot of robot companies do, which I don't think they will, a lot of robot companies, they put a crappy low-grade LiDAR on the robot in addition to vision and the other stuff, because just like with it makes it so you can get your demo working faster, right? You get certain things that but a low resolution, low frame rate LiDAR combined with vision, those could get to be pretty hard to fuse in the same way that radar can be hard to fuse with vision. And so, if they decided that they were going to use those kinds of sensors, then sensor fusion does become a big obstacle to getting things to work. But much like the radar and vision example for the cars. But there are lots of sensors that they just don't collide in a way. Essentially, it's not hard for the neural network to figure out when to ignore one of them.
Got it.
If it's not contributing.
Yeah. So in that view, what is the BevNet style goal that you can give to the neural network that helps to fuse all the different sensors into some, unified model? Is it just actually accurately moving in the space and not falling down? Or is it more sophisticated than that?
So perception is the building block with the biggest challenge in the short run, which is the most important and the one that you have to fix. I mean, locomotion is a little bit separate, but interacting with the environment, it means building a model of the environment, knowing it's a 3D world. And the same one of the things that the BevNet gives you is a way to get the neural network to understand that the world is 3D and to integrate it. And this is a little tougher in the car. If they put a ton of cameras on the robot, so it's got eyes in the back of its head, and maybe the head doesn't move, it might not be necessary to even articulate the head, right? You put multiple cameras around the head. That might be a better, cheaper way of doing it. And if they want to integrate that into an understanding of the entire environment, well, then they got the BevNet problem again, similar to what the car does. And maybe they'll do that, and maybe they would want to essentially copy paste the technique that they used to do that. But getting to where you understand space and objects, like that's a big, it's still an unsolved. You do see models learn it, but we haven't got a good solution for it. We haven't got a good solution where you could just say, oh yeah, we can take that technique, we can stick it in the robot, and the robot will get, objects and space out of it. That's still unsolved. Tesla's doing a decent job of it with the BEV approach. I can imagine there are better approaches. Certainly in the long run, that won't be the approach we use. There will be better techniques. There have to be much better techniques than that. But this is what they've got right now, and that's what's working. And before the robot can do useful things, it has to perceive its environment. And that's still, that's not done. It's not done for humanoid robots right now.
Yeah. I think what's interesting about this discussion is that if there was one thing that I think we might get at the second AI day with Tesla is that I think that insight into how the Tesla bot is learning and what the long-term sort of vision that Tesla has on how these sensors are going to come together, I think are going to be very clear. That's sort of my or at least we're going to have a lot more insight than, say, a Boston Dynamics or whoever else, whatever other robotics company, I don't even know if that's a good example, into how exactly it's doing the motion. I think Tesla's going to be very, very open about it because of that recruitment effort. So I'm really curious to see, I would love to get your take on this specific discussion after that event comes out, because I feel like there's going to be so much in there to learn from for this specific sort of how we're envisioning this thing going forward. Hans, there was also, I know Dojo was another topic that we wanted to touch on as well. Is there something that you want to get us started from that perspective? Or if James, if you have anything else you want to sort of continue on this rabbit hole that we're in right now, or are you comfortable moving into Dojo a little bit?
I'm at my limit just trying to answer questions here. So
okay.
Go
ahead, Hans.
Yes. So one of the topics that came up in the community discussion really centered around Dojo versus. So I think maybe the best way to put it is, just for a lay audience, what is the difference in the requirements from a high level for neural net training versus actually operating the neural nets in the edge? And so they were talking about the limits of hardware 3 and how much farther can we go with Dojo and training large models and still be able to actually run those neural nets after they've been trained in actual hardware 3 in Teslas? Or are we going to need to go to hardware 4 in order to be able to get appropriate use out of the neural nets that can be trained by Dojo? And then there's some follow-on questions about how that training might actually work in Dojo.
So training, training is more compute intensive than inference is, running your model. And just for one thing, when you're training, you forward propagate through the network and see what the error function is, and then you back propagate and update the weight. So at a minimum, you have to maintain the back propagation applies to gradients, where gradient is like for every weight in the model, you keep track of how did it change as a function of this error function. And what those gradients let you do is they let you figure out how to adjust each individual weight in the network after you do your forward pass and you see the error that you got. So you have to keep track of all that stuff. And gradients take a lot more resolution to store. Everybody uses gradients at full resolution. So you need more memory. You need a bigger computer, at least a couple times bigger or whatnot, just to be able to train at all. And you do a lot of training. Well, think about Tesla's forward pass runs on 1 million cars out in the real world, right? So imagine that you were trying to do all of the forward and backward passes in a data center. Well, now you need 1 million. There's this huge asymmetry of hardware between when you look at the whole fleet. Remember, the whole fleet is gathering data that goes back to the training center, right? So at a minimum, you're going to need, if you're going to have a computer that can ingest data from a whole fleet of cars and integrate that, even if you're cherry picking the data from the cars, it's just a lot of data. So so you do a lot of training, and training is a development process and it's empirical. So a lot of training, like, it's never the case that you make a change to your corpus or you make a change to your training algorithm and you know what's coming out the other end. Right? You make those changes and you see what comes out. And sometimes you don't like what came out the other end. So the thing is, you train a lot. You do it over and over and over and over again, right? You train different ways. You change the hyperparameters. So Dojo, if the machine that you want in your data center, you're just going to train a lot of neural networks all the time on enormous amounts of data. And so, you can't really compare the hardware requirements, because the car in the field, it's just running one version of the neural network, like in real time. And the one in the data center, it has to run it many, many times real time so it can get through that whole data set. And it has all this other stuff that it's got to keep track of. And you're going to do it over and over and over again. So you want it to be fast, because your team is sitting around twiddling their thumbs, waiting for the results before they make their decision about what they're going to do. So the requirement is totally different. One other point, which is worth considering on the hardware 3, hardware 4 thing. So when you're training a neural network, the neural network that's getting trained, it has to have the capacity not just to do the job, but it has to have the capacity to learn the job. And learning the job involves exploring all these different ways you could go about doing the thing you're being asked to do. So neural networks in training, you want them to have a substantial amount of excess capacity so that they can simultaneously explore many different, ways of doing every particular little thing it's got to do. So you want them to have a lot of capacity. And the bigger your neural network is, typically the faster they train, because the more excess capacity it has, the faster it converges on good solutions, adequately good solutions. You can prune that whole thing down to just the one good solution when you put it in the car. And there are different dimensions on which this is true. One thing you can do is you can literally prune the net. Like, you can make the neural networks a lot smaller if you want to. You can also you can do an analysis on the neural network where you look at where you need precision and where you don't need precision. And you can reduce the precision of the parts that don't need precision to provide good results. And this makes them a lot smaller. The neural networks that run in the car, they're all 8-bit integer neural networks. And the ones that they train are 16 or 32-bit floating point networks, and they have to have the gradient. So in the hardware that you want to run in the field for doing inference and the hardware you want for training, they're just in two completely different universes in terms of capacity. And in an interesting way, the more capacity you have in your data center, the less capacity you need in the field. There is a trade-off there, because that process of training the neural network and then pruning the neural network and then doing the precision analysis and shrinking it down, like that also take compute cycles. And the more excess capability you have in your data center, the more time you can spend doing that. So in an interesting way, like if your Dojo is 10 times as powerful, maybe your hardware 3 only needs to be half as powerful, right, to do this stuff. Now, as to whether or not, hardware 3, like the specs it has right now, are sufficient to do the job, or, there's this trade-off that Tesla's doing right now. Like, they could have, and I think the original GP106, which is like 20 times slower than what they have in hardware 3, I think if you have, once you've got a really good solution for FSD, and some group of guys just goes off and they sit down for a year and they figure out how to make it really small and squeeze it and take out the stuff and whatnot, they might get it to run on GP106. I mean, if you're talking about what's the minimum floor necessary at all to ever be able to do the job, it's probably pretty low. But, we don't want to wait that long. We want to push a new release next week. We have these other things we'd rather do. So instead, you end up with like this economic trade-off. Like, what's the biggest computer that we can cheaply put in? Because, computers these days are like, if you make your computer 10 times less powerful, it doesn't get 10 times cheaper. Like, there's a sweet spot, and it's a moving target. And hardware 3, it was the sweet spot a couple of years ago when they did it. Hardware 4 will be the sweet spot when it comes out. Like, it'll be in that sweet spot. It's not overpowered. It's not underpowered. It's none of them is the bare minimum necessary in order to do the job. You could go lower, but your development would get more expensive. And there's no point in making your development more expensive or delaying your product if you're only going to save $5 on the computer, right? So it's a game of optimization. Like, what are the possibilities? Not like what's
Best bang
the
for your
minimum
buck, basically.
Yeah.
Yeah.
So is your intuition then, because I think a lot of people are basically extrapolating the fact that current FSD beta uses both sets of hardware on the hardware 3 chip instead of allowing it to be fully redundant like it was originally designed. And they're inferring from there that, well, it's just too big and that's why they're hitting the limits. But so are you saying that basically your take is that potentially they're just using all the resources that they have available because it allows them to do the fastest development research? And
so it's a misunderstanding, the idea that the design is that you run these 2 identical copies of a neural network. There are lots of ways to get redundancy, and that, especially with neural networks, with some kinds of algorithms, like that's the only good way to get true redundancy. But with a neural network, you don't need to do it that way. Especially in like a self-driving car application, you can have a limp mode. If you've got twice as much compute, and you like, why restrict your application on it for 99.99% of the time you're going to use it to only using half of the compute and throwing away the other half, even though you're paying for it and you're running it, right? A better approach is to size your algorithm to the compute resources that you have, and have a flexible, a graceful way of degrading down to perhaps significantly lower capability, so that you can limp to the side of the road or you can limp home. At a minimum, the reason that the hardware has to be completely redundant is if a chip dies, like that chip is gone. It's like 100% gone. So you have to have a replacement for that chip. Now, in Tesla's case, they made a SoC. It's a system on a chip, their core thing. They also have power supplies, camera inputs, and so forth. They put 2 SoCs on because if a SoC dies, it's just completely gone. And there's no limp mode if the computer's completely off. So at a minimum, you put 2 chips on there. And it's cheaper to put 2 chips than to have 1 big chip and 1 small chip or whatnot. You know, the chips, they're not that expensive themselves. So you put 2 chips on the thing, and then you cross connect everything. So all the power supplies are connected to both CPUs, and all the cameras are connected to both CPUs, and so on, so that any individual component, hardware component, can fail and you can still limp. Like, that's smarter, because if your system makes 5% fewer errors, if you run twice as big a neural network on twice as much compute, and that's what you're going to be doing 99.999% of the time, well, you want to do that. You want to spend your resources on that. The arguments are, people trying to read the tea leaves and guess at whether hardware 3 is sufficient or hardware 2. Like, that's really hard. Like, Tesla doesn't know that. Like, nobody actually knows that. If you really wanted to know, is this hardware adequate, you'd have to do a design study around that. And you'd have to really look at all the, and nobody's going to spend their time on it. They have a platform. They picked it to be the sweet spot for the basic economics of the computation requirements of the application. And they build against that target, and they make the best system that they can within that envelope. And if they have a bigger envelope, they can make a better system. How much better? Well, you kind of have to build it to find out. So we don't get hardware 4 because hardware 3 is inadequate. We get hardware 4 because there's like no point in continuing to buy hardware 3 when you can get a cheaper, better computer, so that's why hardware 4, and there will be a hardware 5 and 6 and 7 and 8, and they won't necessarily be because like hardware 4 didn't work. It's just, who has an 8086 in their iPhone, right? I mean, we just don't buy those old computers. Once the new one is there and it's at the same price, you use the new one because it makes everything better and easier, right? So yeah. I have a very different take on this stuff than some of the dialogue I've seen sort of guessing at whether or not it's going to be adequate. Neural networks are incredibly fungible. Like that doubling the performance of your neural network sometimes only gets you 5% increase in performance. Doubling the CPU, doubling the memory, doubling the data. Like these neural network scaling is log scaling, right? So your error goes down with the log of the size of your database. So, if you can get twice the compute for the same price, well, you take it, right? It's free. But you probably don't spend twice as much money for twice the compute, because it's rare that 5% increase in functional accuracy of the system at the end of the day is a make or break for your application, but it might be a make or break for your economics. Got it.
That's super helpful for me to understand better. So I really appreciate y'all sort of helping us think through that. So to me, like as a layman, so what it sounds like to me is just Tesla's getting they've been getting very, very good at optimizing the amount of hardware they have available to themselves to become much more efficient with the capabilities of the car. So they're using everything that's available to them to make the car do more things, right? And to be able to do it quicker and to arrive to the end goal faster with the same amount of compute. And so how does the 36 frames per second change? I don't know if it's live. I forget if it's live it or not. Maybe Hans, I think you proposed this question, but how does this fit within that sort of encapsulation of Tesla going on this march of really maximizing the hardware that's given to them? Maybe help us think through that a little bit, if you don't mind.
Yeah. So was it Hans? You asked about the 36 frame per second frame rate change and what the.
Yeah, it was one. It wasn't one that I had proposed, but it was a question that came up in the community, and they were asking what the impact of moving to 36 frames per second for FSD was going to be on the overall performance.
And then Hans, people want to know what you're eating.
Goldfish.
Goldfish.
Oh my God.
Yeah, somebody wanted to know what James snacks on when he's super deep thinking about the future.
That's a good question.
AI. What
do you like to snack on, James? Yeah.
Sugar is bad for me. I love it,
okay,
but it gives me headaches, so I don't eat very much of it. My girlfriend my wife is an incredible cook, and so my kitchen is a minefield. My favorite ice cream is there's this boutique ice cream maker in San Francisco called Humphrey Slocum, and they have this flavor that I like. It's called Secret Breakfast, and it's bourbon and cornflakes.
Whoa.
it's just so good, and you can't get it here in LA. They don't seem to have a store nearby, so she makes it for me, and I have to stay out of the kitchen when it's down. It'll just be gone in a day if I do. No, I love snacks, but they're not good for me, so I stay away from them mostly.
Okay.
I like water. Water's good.
Nice. Yeah, me too. I was drinking some tea before and I got water. Sorry, go ahead, James.
Yeah. So the frame rate, I think the biggest change in frame rate is it makes the system simpler. If you want to run different parts of the system at different frame rate, we know the cameras run at 36 frames. And so all the data comes in at 36 frames. Because everything flows from the frames that come in from the camera, the simplest design is just like set of frames comes in, chunk, chunk, chunk. You have a pipeline. Everything moves one notch down when a frame comes in. Like that's a simple synchronous design. But you could imagine that you might at some point in your development go, God, we really want to run this part faster. And if we run it faster with the code base that we have right now, we got to slow something else down. And you could see some other guy saying, well, this part of the neural network, it only needs to update every second or every 3 times a second. So we'll slow this down and we'll make that part faster. And now you've got parts that don't all run at the same speed. And it might be fine to do that. It might not be much of a performance impediment, but over time, what happens is the part you wanted to run faster, you find other ways to make it faster. There's other optimizations you can do in the system. So maybe you bring it all back to 36. And you can imagine that once you start running different parts of the network at different speeds, now you have this whole thing of like, do you average? Do you buffer in between? Like, how do you deal with the rate mismatches? And it adds complexity. And there might be points in the development when that's something you're willing to accept because your guys are sure that this critical problem that's been beating you in the head, it would be better if we just ran this part of the network, twice as fast. And so you guys go out, they figure out a way to do that. But getting the system sort of optimized or throwing away, like the other thing is they have all this stuff like shadow mode. They have all kinds of stuff that runs in the system that isn't necessary to drive the car that they use for taking data and that stuff. And maybe at some points they decide they don't need it, or they have a legacy neural network. Like one of the things that we saw was, this is like it's kind of like biological evolution almost. They end up with these vestigial neural networks that were really important like five versions back, but they're hardly using it anymore. But they haven't gone to the effort of like actually designing it out, migrating that function over to some other neural network. So stuff gets bigger and then they trim it down, and then it gets bigger again and then they trim it down. And after a trim cycle, well, that would be the natural time to go to 36 frames, because all of a sudden there's this stuff you're getting rid of and that frees up some resources and you can use it to go back to 36. Why Elon? So Elon had a tweet where he was talking about getting the whole system, or I think it was a comment, actually, a verbal comment on stage someplace, where he talked about going back to 36 frames. And what it does depends on what you're not running at 36 frames and what that trade-off was. So it's pretty hard to predict. But one thing it definitely does is it makes your system simpler if you just run the whole thing at 36 frames. So I would imagine there are some bugs that will go away when they just run the whole system at 36, because it's not easy to build the system asynchronously.
Okay. Do you think that change gets made in 1069, or do you think that's a different place where that gets changed?
Like Elon's track record for predicting what's going to make it into the next
worst
release is not right on.
Yeah. Well, at least he keeps it interesting. Now it's just saying he keeps it interesting, keeps us guessing.
Yeah, I don't.
That's true.
There's a population of people who would rather he shut up and not say anything that wasn't guaranteed to happen. And I'm totally at the opposite end. I just want to, like, if he was on Twitter all day long and it was just stream of conscious and 90% of it was BS, like that would be great, because that would be more information. Like I'm willing to sift through and I understand that people who would rather see him talk less are concerned about public response, to potential negative consequences of people who don't know him or don't know what's going on or whatever. Yeah. And I tend to not actually think that's that important. Maybe it is.
I agree with you, because I feel like that's the reason. I feel like that's the hook that he has for the layman to get excited about a lot of the stuff that Tesla's working on. Like almost like that, hey, FSD is going to be able to do these things. The bot's going to be able to do these things. It's what gets people excited about these new technologies that are coming out. I mean, the reason why I was even part of the community in the first place was because of the grand vision of electric vehicles. And I like cars, but I don't know how electric vehicles work. And then I became a huge nerd when it came to electric vehicles. So I hope he continues down that path, and I don't think he's ever going to change. I mean, it seems like he's has his mind set up. Yeah.
He seems like he's getting quieter lately, though. I hope it's because he's just distracted with other things, and because Twitter's probably not a great use of his time. Sorry, tweeting on Twitter is probably not a great use of his time. I like to hear it, and he's my people. Like everything he says makes sense to me, right? So like I don't have difficulties with him talking as much as he wants to, and people do seem to get really upset. I'm shocked at how divisive a figure he is. Like the negative reactions that people have to him shock me.
Yeah. I actually was doing a little experiment on Monday. I went to downtown Austin, and one of my video ideas was I'm going to ask 100 random people on the street what they thought of Elon Musk. And I was just going to wear a black shirt. I'm going to make sure I'm not, nobody can tell I'm a Tesla person. And I only got 2 people to talk to me out of 100. I'm like, damn it, I want to know what you're thinking. I want to know what you're thinking.
But because they wouldn't talk to you, or because they didn't want to talk about Elon Musk?
I think some of them were because of Elon, and some of them were because they didn't want to talk to me, period. So it's like I was trying to get into the mindset of how like the broader public thought about his sort of like just what they thought of him, because we get a certain angle from certain folks that are saying, he's crazy person on Twitter saying all these insane things and he's very divisive. And then we have people in the Tesla community saying he's actually a very unifying person because he's kind of he's a magnet for people that want to move the future forward, so it's a very interesting dynamic, and I was looking to explore it. But I think maybe because it was a Monday evening in Austin, I think everybody's just getting home from work and they just want to go home. They don't want to talk to some random guy walking around.
It's I flip back and forth between thinking that it's mainly the media that has a problem with him, and they have the megaphone, so we get to hear, so you get a distorted impression of, because people I meet in my real life that I talk to. But then I read the comments on some article in the Wall Street Journal, and I'm just like, really? People really think that? Like, so I can't, maybe they're not representative. I mean, it's also a media kind of, interchange thing. It'd be interesting to know how people really feel about him, like the public at large. And I would like to see the opinions weighted by importance, if you will, right? Because it's one thing to just get a spread, but some people like to hate him, but they don't care. It's not a big deal.
Right.
And some people, they love him and it's the center of their lives, And so like, I feel like, if it's a big deal to you, like if it's something, then I would like somehow to see a poll that weighted that. So you could see, on balance, where is the energy in society going? What do people who are willing to go stand in a picket line and that kind of stuff,
I'm curious to get your take on that too. Like, I mean, you're somebody who comes from a very, you have a great technical background in AI, and Elon and his companies, they're like these things and culture that are bringing these things forward to the masses, and it's almost like bringing light into the amazingness of these things. Like, how does that make you feel? Like, because I'm assuming it's
during the Apollo era.
Okay.
I feel like I think it's really inspirational to engineers these days that there's like this thing going on and stuff is happening, and it's good stuff. The world's going to be a better place. And engineers play a big role in it. I mean, engineering was really central to the Apollo program and all the space stuff. And I don't know, man, I know so many people who they were inspired to get into the profession because of all the attention that it got at the time and how fun and interesting and challenging and rewarding and meaningful all of it seemed at that point in time. And having the space program go away, it kind of left a hole. I mean, certainly there are other things, but in most countries, I don't, in Germany, engineers are like accountants, or, and famously in the East Bloc countries, like being an engineer is kind of a low grade profession. It doesn't get as much respect as a lot of other things, and it isn't compensated as well. In the West, we treat engineers a lot better, but it's not clear to me that people go into the profession partly because it's a safe job, and it's well compensated. But a big part of it for most people who get into the space is that they like the topic. But people going into engineering because it's inspiring, they're going to change the world. Like, it's a powerful thing. They're a force for good. Like that it felt like that kind of went away for the last couple of decades. And once again, people have different feelings about Elon, but I feel like Tesla and SpaceX, they made it cool to be an engineer again. And I'm super thankful for that. I think engineering is really important, and it doesn't get the appreciation it needs. And in engineers, there's a personality type of people who really get into it, and they're not good at selling themselves. They're very, I don't know, they're classically introverted and they're dorky and they hang around with their friends and they're not politically active usually. I mean, I don't know. I feel like it's been good for engineering to have it out there. It's been like, my life would have been really different if Tesla, because man, I would have been on a train to go work at one of those places if that had been an option. When I came out of school, like, it wasn't easy to make, being an engineer was kind of like being a construction manager or something like that. It was like, yeah, you did it and it's kind of interesting, but only certain people are really into it, sort of stuff. Yeah. And now, it's not like that anymore. It's changing the world again. It's good.
I mean, I can tell you the profound experience that I had recently that I think really etched that sort of mindset in me is the Giga Texas opening, which you were there as well. I think that's where I first met you. The thing that stuck out to me the most was, and I wasn't even expecting this, but it did. in the parking lot, you have this great variety of cars. You have gas car, sedan, huge pickup truck with longhorns on it, a bunch of Teslas, but just a bunch of variety of cars in the parking lot. Then you go in and you see a very diverse group of people, from all backgrounds. And I was talking to some of them, kind of like, hey, how you doing? Where you from? Blah, blah, blah. But it was a very diverse group of people. All of them, not all of them, but most of them with a drink in hand, walking around, marveling at engineering that was at a company that was built by an immigrant in the United States. And I'm like, this is the American dream at force, but super focused on engineering and technology and the future. And at that point, I'm like, holy shit, this is humongous. Like, this is way bigger than just product. This is cultural. This is a culture thing that's really starting to develop, and it's diverse and very broad in its reach, but it's focused around engineering. It's focused about the super nerdy stuff that, when I was growing up, I actually went to school initially as an aerospace engineer, and I just changed to math because idiotically I thought that was going to be easier, but it ended up being even harder. And I'm like, I'm not going to be the dumbass that's going to switch back and forth between two fields. I'm just going to stick with one kind of thing, and finish my career. But, it wasn't really looked at as, at least when I was going to school, it wasn't like this really cool thing. But now with what Tesla and Elon are doing, I feel like you said, that fire, that passion that's coming back into engineering and what it means to build things. And the fact that we get to have it here is like so cool. It's so cool and not well understood to this day by the masses. I think that part of it's still missing, that the cultural change that these companies are making, I think are pretty vast and not well understood. Yeah.
How much of it do you think is SpaceX and Tesla are incredibly disruptive to the industries that they're in, and they've been disruptive in a pretty eye-opening way. Landing rockets on a ship in the ocean. It's very eye-opening, right? Or building these 1950s era, space opera rockets out in, out in the open. And, Tesla, the cars are sexy, and people really, incumbents really love to hate on the company. So like, they're disruptive, like they get attention because they're disruptive, and they get a lot of hate because they're disruptive too. But do you think that it's that disruptiveness is what drives all of the kind of frenetic attention that the companies get? Or because on the other hand, you see people argue that Elon's like P.T. Barnum, like he's really good at getting attention for his companies, and that a lot of the stuff that they do is basically an engineered effort to just attract attention.
Yeah, that's a great question. I would love to open this to the panel as well. So if Hans and Ishan, you guys have thoughts about this, I would love to hear yours. Like the way I think about it is it's like the perfect storm of really cool things happening all at once. So Elon is somebody who comes across as a real person who happens to be very smart. He's very charming. He knows how to joke around. He's willing to go on 3.5 hour long podcasts and talk about whatever. So like you have an individual that's leading a company that's making himself very vulnerable to the people, especially as a CEO of a multi-$100 billion company. That is completely unheard of. Usually these guys are super closed off and just put in a box, and like their job is to just not say anything ever, go into quarterly calls, talk about how great the company's doing, and just disappear for 3 months, right? So that is like what the usual CEO is. So you have that. Then the products, kind of what you talked about. I think that disruption of having the super cool car, the super cool rocket, people can actually see and feel the things that are being made. So I think that in itself is very transformational for the experience. I think this fucking adult chatting bot in the comments is driving me nuts. Go away. It's because it heard us talking about the bot. I guess it's coming in. I think that. The products itself being sexy and the products themselves being something you can feel are transformational. I think if he ever buys Twitter, I think that's going to open a gigantic number of people in the population that have never physically touched one of his products before or experienced one of his products before. Now they're going to get insight into what it means to experience an Elon product, something that's going to be best in class. It's going to change all the time for the better, and you get to benefit from that change. Most people have no idea what that actually feels like. They've heard it, they've seen it, so then that gate opens as well. And then you have the mission. So I think the mission in itself is so inspirational, and it's so inclusive. It's like, hey, let's move the entire world to the future. Let's all go together and ensure that we're not killing our planet, make sure that we can survive as a species long term. Let's make sure we have an insurance policy down the road with Mars. Let's work on all these great things that's gonna make humanity like better in the long term for all of us, not just a specific few, for all of us. And yeah, and there's probably many more, but like those are the three things that really stick out to me. It's so unique. It's so unique and weird. Like, and then I've been thinking about this too. Like, is it really that weird that we have that singular company and mission and thing that's driving so much inspiration? Or is it weird that we don't have more of those in the world? Like, which one's weirder? That one or the other one? Like, is it really that unique, or have we just accepted this being super exceptional and everything else is just like blah? I've been thinking about that a lot. I don't know what the answer is there, but yeah, that's my answer. I don't know if anybody else wants to riff on that, but that's where I land. Yeah.
So, I mean, part of it was you were agreeing with the P.T. Barnum thing of attracting a lot of it, because a lot of people talk about like trying to save the it's kind of it's a cliche in Silicon Valley to have a mission, and to have your 5-man startup be dedicated to saving the world. And but I mean, Mary Barra, she'll say it too if you ask her.
Yeah.
I lean more on the disruption side, though, because I think that a lot of the attention, I mean, the FUD attacks create a lot of attention, and both positive and negative. And if the technology itself wasn't honestly threatening to so many existing industries and players and institutional money, then I don't think that you would have the concerted effort to really try and take it down. And then without that concerted effort, like that's what drives the actual attention in the legacy media most of the time. And so that kind of creates the perfect storm. And so I think it really is both. And, is to kind of address your question about, well, is it weird that we have this now, or is it weird that we don't have it? And when you see the pushback against it, how many people have had all of those ingredients to be able to push through that were necessary? Like, if kind of like Elon talks about the supply chain, to make a car, if one of the thousands of parts is not there when you need to make the car doesn't get made. Well, what if one of Elon's ingredients that he needed to be successful wasn't there? Would we have Elon? Would we have Tesla? Would we have SpaceX?
What if Zip2, did not work out the way it did? Who knows? But, I look at it from a different point of view. Like, I don't look at Elon as a CEO. I look at him as an entrepreneur and a bootstrap entrepreneur, right? Somebody who doesn't start with raising money, but starts with building. And if you look at any founder entrepreneur who's actually building or built a bootstrapped startup, you'll find a lot of these similar qualities. From personality wise, cultural, work ethic, the effort that they put in, the passion that they bring, and abilities as well, right? Not everybody has the ability, just in terms of, pure IQ and skill sets, etc., to actually do something like that. I think what is pretty rare is the fact that Elon does seem to have like super amazingly exceptional ability in terms of what rests between his ears, but in terms of qualities, in terms of the fact that he's ready to put himself out there, I think a lot of this you'll find in a lot of entrepreneurs who are doing or have done these bootstrap startups. Another difference being that, yes, like Hans rightly said, the FUD attacks, etc., they put a spotlight on him. The richest person in the world has put a spotlight on him. So he's basically got this megaphone now. But back in his, early Tesla days, or, Zip2 days, maybe, X.com or PayPal days, he did not have such big megaphone. Was he doing stuff that was not revolutionary? No, he was. He's completely changed the way we bank, right? He's completely changed the way he's basically, if you think about it, right, he's one of the first people to create an online advertisement ecosystem. The and that Google runs on it, Facebook runs on it, world's biggest tech companies run on a simple idea that Elon Musk first, or was probably one of the first people to try out, putting yellow pages onto the internet, right? It's the first form of advertisement on the internet that had happened. So if you think of it from that point of view, right, he's changed our lives multiple times over. But it's only now, call it money, call it all the fun attacks, but the real, disruption after disruption after disruption he's affecting has really put that megaphone on him. So part of it I'll put down to, him, and part of it to the changing environment around him.
Interesting. Yeah.
An interesting data point for me, like I worked in EVs, and I have a lot of friends at the Jet Propulsion Laboratory. So I was familiar with electric vehicles, and I was familiar with rockets before Tesla and before SpaceX. But, I really didn't pay any attention to Tesla or SpaceX until they started looking at landing rockets. Like that really got my attention. And when, having worked in an EV startup, I know very well that EV startups all fail. And seeing somebody succeeding at EV startups, like that was very eye-opening to me. So for me, like I started noticing the accomplishments, and then that was the thing that kind of turned me on and got my attention. But I don't know he is a character, and I haven't been able to get my head around whether in the popular conception, what he accomplishes is more important than, the kind of personality that we hang on him.
Yeah.
He's not the only eccentric person that we know, right?
I mean, Richard Branson is famously eccentric, and I don't feel like he gets nearly as much attention. I mean, eccentric entrepreneurs are not rare. I mean, even Jeff Bezos is kind of weird, right? I mean, they're all, it's, Bill Gates, Sergey and Larry, who have vanished off the face of the earth. They're
not as much. I mean, Richard Branson gets a lot of press for all the stuff that he does. You add a 0 or 2 to his net worth, and that I think will exponentially increase the coverage that he gets, is what I think. But I mean, at some level, the coverage, the megaphone, that size thing is an exponential function to the number of zeros that you have in your net worth. And it's the world that we live in, right? It's basically what gives people a dope hit in their brains. So
Yeah, for most people anyway. Yeah. Hans, I wasn't sure if you're putting up your hand before, if you're moving your thing around. Okay. Awesome. Well, we're approaching almost 2 hours, James, and we've been peppering you with questions like crazy, and we really appreciate you taking them on. But maybe if I can throw one more towards you, if that's okay. So we were talking a little bit beforehand. I'm just curious to get your take. And I'm not sure if you covered this with John today. If you did, please let us know so we don't have to cover it. But 1069, there's been a lot of discussions around that firmware. And we had Chuck Cook on a couple weeks ago, and we spent an hour and a half talking about left-hand turns, like left-hand unprotected turns and his experience. And that's all we did for an hour and a half. And I was surprised we went an hour and a half, because I'm like, this is a half-hour topic. Nope, it's at least an hour and a half. It could have been 3.5.
More than that.
Yeah, for sure. What are your expectations for the release? One of the things that Chuck brought up was that he believes that there may be additional cameras needed to actually ensure that turn gets completed 100% of the time. And there's been some footage lately of like the ADAS systems, or like the ADAS testers out there and trying out Chuck's turn over and over again. What are your expectations? Do you think this thing gets solved with the current setup? Do we need more hardware? And yeah, maybe talk a little bit about where you think we're going with.
I don't think the hardware is a significant. So I know there are a lot of people who feel really passionately that more sensors would benefit the vehicle in important ways. I do not share that sentiment. I tried to do a little analysis. Chuck was nice enough to share with me a bunch of his videos. And because I was curious, like first principles, like how would you ask this question about can the car see well enough to make a turn? So in the world, there are places you safely can't make turns. Like there's the way that Google wants to route me out of my neighborhood, it wants to route me off of a narrow suburban street that's parked on both sides, past a building that always has large trucks parked in front of it, onto a street with a 45-mile-an-hour speed limit where the traffic is frequently going 50 miles an hour, 60 miles an hour. And, depending on the configuration of vehicles, you just can't see down the street, right? Until the front of your car is well out into traffic. Now, of course, the world's complicated. There's this woman who lives on a street not far from me who backs her car into a 50-mile-an-hour speed zone and just blind every morning.
Wow.
Like, I don't know how she's managed to live this long, but apparently she's lived in that house for 20 years. I don't know if she times it, if she looks down the street before she gets her car, she just backs into traffic. And people in the neighborhood, they know that she lives there. Like, this is the adaptability of traffic, right? Things that seem like they shouldn't work, they do actually kind of work most of the time. And occasionally they go horribly wrong, but they mostly work most of the time. And people kind of rely on this. Like if you've ever had to back a really big truck out into a street, that one of these moving van type things, there's a certain amount of praying associated and hoping that the people in traffic, relying on other people to not do the wrong thing when you do that. And mostly it works out okay. I mean, that's part of the world. There are streets that are just totally blind. You just can't see until you're out in traffic. And it's a street you should avoid driving down. I mean, these are things that occur in the real world. So there isn't going to be any hardware solution that makes it so you have perfect knowledge in all situations of what you don't get there. The reality is that you have a sensor suite and it covers a certain set of cases. And if you add more sensors or you change the sensor suite, you can increase the number of cases that you cover. And where do you draw the line if there's never enough sensors, right? My belief is that the sensors they have on the car right now are not bad. And I went and I looked at some problematic turns that were where somebody stuck a GoPro on the side of the car, right where the B pillar is, and they drove up at a bunch of difficult turns and essentially said, here's where I'm comfortable. Here's where the car was doing something that I didn't think was comfortable. And I asked myself, how much time, what do you need? What does a camera need to be able to see in order to, objectively make a safe turn? So, I looked at some videos and I decided that you need 5 seconds. You need to know there's nothing coming for 5 seconds on almost any road with the speed limit up to like 50 miles an hour. So say to be comfortable, you want to see 7 seconds down the road. So if you can come to an intersection, not crawl into traffic, and at some point along there, you can see 7 seconds up the road, that's enough. Like that, in my mind, that would work. I couldn't find any examples online that didn't meet that criteria. That doesn't necessarily mean people are going to be happy with this. One of the things that you get when you start using FSD, I mean, the first time I got in the car, I was like, I bought my first Model S. I bought it for autopilot. I drove it out. Like I went down to the factory and I picked it out. I put it on the freeway and I turned it on. Like it wasn't 5 minutes between the time I turned it on. And I let it drive me all the way back to San Francisco in traffic. And it wasn't very good, right? This is the first version of AP.
Brave.
And the first time it had to break when I was in traffic. I mean, everybody's got AP has this experience. Is it going to stop? Is it going to stop? Is it going to stop? You watch it stop. And then the second, third, fourth time, you're amazed that the car stops, right? We don't trust the technology, and we shouldn't necessarily trust the technology. If you come up to an intersection and the car's cruising along, and it's going to stop at some point, ideally before it enters the traffic, and that there's fast traffic coming, you have less tolerance for letting the car do whatever. Like, you're more sensitive to what the car does than you are yourself. Because if it goes a foot too far, you're imagining disaster. Certainly, if it suddenly starts to accelerate, even when you go down the street, you can see that it sees the trash cans. You can drive down. I drive down my street. Every time I leave the house, there's trash cans on the side of the road. And every time I'm like, is it going to see the trash can? And it always sees the trash can. I still don't trust it to see the trash can. So I think there's some of this psychology at work. We set a higher bar for the car because we want it to stop a foot or 2 or 3 feet short of where we feel we would need to intervene. And of course, people aren't good judges of having your nose stick into traffic a lot. Like that, you can look on Chuck's videos, and an observation other people have made, and which I agree with, is that frequently when you see him stop in his videos, feeling like he's getting too far into traffic, he does these drone shots from above. And you can see he's still got 6 feet that he could move forward before his nose is in there. But there's that comfort that he's got. Well,
so
when the software's good and when we trust the software, right, then we ask the question, are the sensors adequate? Like, can they actually do it in a way that isn't going to endanger us? And my belief is that the current sensor suite is capable of doing that. You could add more sensors and they won't they won't necessarily degrade performance, but it's not cheap. There's 8 cameras on the car right now. If you add 2 cameras, you got to slow everything else down by 25%, right? All the other cameras got to run 25% slower. The whole system's got to run 25% slower because I got 2 more cameras on there. So you ask the question, that's a trade-off. If you just put the cameras on and you don't add more computers. If I put more cameras on and I put more computers on, I make the car more expensive. And, that it has knock-on effects and that kind of stuff. There's a sweet spot for price and capability. And when I look at the whole envelope of all the stuff that's going on, I see, that 99% of everything that they've got to do is software. And maybe there's 1% of stuff that needs hardware to change it. And I just don't want them to focus on the hardware. I don't think it's important enough that it should be driving the discussion at this point. Because to me, the software is so obviously far short of where it can be and where we want it to go. When it gets closer, like when we can see the real limits, then let's talk about whether we need more sensors, right? Or if the sensors are the right ones or whether they should move around, because then we'll be in a much better position to understand. But I can't find any simple argument that I can analyze on paper that tells me, yes, these are inadequate. They need to change.
Got it. Got it, Ishan.
So, James, do you think at some point there will be some network effects coming into play here where as the number of semi-autonomous and autonomous vehicles on the road increases, the roads inherently become safer, and what currently today is a dangerous turn will become safer because a vehicle coming from the other side will also see this and will tend to slow down instead of the human today who tends to speed up.
Yeah, actually, I do think that adding, safe, mature, self-driving cars to the traffic mix is probably going to have nonlinear effects on safety. I don't think you have to get to a point where like all the other cars are self-driving cars. Traffic is really sensitive to, the lowest common denominator. There's this group that does traffic studies here in Los Angeles. Los Angeles is a really popular place to do traffic studies. And there was this set of academics, and they were trying to like validate this model that they had of this granular flow dynamics. And so one of the predictions of their model was that there's this non-reversible phase transition that traffic goes through. And they were trying to use this to inform highway design. And they did this demonstration where they said that when traffic gets into certain circumstances, right, one vehicle on a giant freeway can cause everything to cross this, to do the phase transition, to stop and go. And they did this by doing it. Like they would have a freeway that was going just fine, and they would have a train driver get out there, and he would do the thing where he would slow down in the right circumstances, and blam, the freeway was locked. Like they did this 4 or 5 times, to gather data for their simulator, whatever the deal is. It doesn't take very many cars to change the way that traffic flows. And I suspect if you had 5 or 10%, good behaving self-driving vehicles out there, essentially, with a nice, safe follow space and, following the road rules and whatnot, that there'd be a significant number of places and times where the dynamics of the traffic flow would change in a meaningful way, and things would just get safer. Because people can be dumb.
10% is the inflection point that
5 or 10 is pretty significant. And it doesn't change every situation, but it changes it changes enough that you'll start seeing it in the highway accident statistics.
And you expect this to be another sort of S curve in terms of safety? Safety or ease, maybe?
I think it's going to be hard to see a lot of these effects, unfortunately, because, you're not going to have your 1-year window when you were right at 10% and you can gather a lot of data, right? Everything's going to be changing really rapidly. And we're only going to have good data on the beginning and the end of the S curve. Like in the middle, so many variables will be moving. It'll be hard to make an argument about, what was actually happening and what were the causal relationships between all of these different things that you're observing. At the end of it, I think, one of the reasons I've always been interested in self-driving cars is because the traffic fatality number comes up a lot. We talk about the 40,000 people that die, but we don't talk about the 2 million people who go to the hospital, right? I mean, or the trillions of dollars of property damage that occur every year. I mean, cars. This is I'm simultaneously amazed that we have people on their phones or who are sick or tired.
Surprised everyone's alive.
They're in a bad mood. They're having an argument with their spouse, and they're driving, with negative margin down the road way faster than they should be going. And it's not a total bloodbath, right? We go, 400,000 miles between significant accidents. And it's like 100 million miles of driving per fatality. Like those are pretty amazing statistics given what I see other people doing when I drive my car. But the flip side is we drive so many miles that it's still a huge burden on our society, the consequences of this, and as an engineer, I'm offended by it because it's solvable. Like it's such a solvable problem. We should solve it. It's like, what is it? It's like a 9/11 every week or something like that. It's the carnage is just, it is insane. Why do we put up with it? We should fix it. We've got the frog and water situation where, we grew up with the car, our society's evolved around it. And we have this incredibly, in automobiles, they're the number 1 cause of death for people under the age of 35 or 40 in the United States. I mean, like people in the prime of their life with so much to go forward for, they end up, quadriplegics or they end up dead. And we just put up with it because we're used to it, because we got here step by step over the last 100 years. And it shouldn't be okay. We should fix it. We can, and we will. Like self-driving cars, I think they're the solution, which is practical to this problem that you can add. Because the other thing, like you could try to force people to be more reasonable. We could raise the requirements for getting a driver's license really high. I mean, you can imagine all these different ways you could go at doing this. We could add more crash barriers and rubber boundaries and that kind of stuff. Those things are all really expensive and complicated, and they're not going to happen. But self-driving cars, they will happen. And so I see them as a solution, and it's almost like a moral crusade.
Yeah, I've heard you talk about that before with Dave about how just important that is. And what the unfortunate flip side of that is that it's almost like predictable nowadays, especially if the media landscape remains for the next 5 to 10 years as FSD and self-driving cars become more and more common, is that the opposite narrative is going to be driven, where are you going to trust the car that you are not controlling right now? It's a very predictable sort of a place that we're going. What can we do to change that narrative that's likely to happen? Or are you optimistic that as we get more of these on the road, that more and more people are going to be willing to adopt this technology? Or do you think it's just going to happen regardless? Do you think this is a thing that's just going to happen? It's going to be forced and the lever is going to be pulled, and before we know it, we're all going to be we're not going to be dying from car accidents? How do you see that?
I think it's media that's excited about it much more than it's surprising to me how many. You have the conversation with somebody, just some random person that doesn't think about this stuff all the time and isn't a Tesla nut. And, maybe they've seen some articles and you talk to them, you give them a ride, you show them the thing, and they're not super committed to a perspective at that particular point. And they have a personal experience with it, and they very quickly converge on a very reasonable expectation. Oh yeah, it's immature. It'll take a while to get there. It might not be perfect. You should pay attention. But over the long run, it'll be a big improvement to people's lives. I mean, people get there.
Yeah.
If we're fed a diet of hyperbole from newspapers that are trying to get us to click on an article, then you end up with a particular perception. But people don't seem to get really committed to that. They're not really invested in that opinion that they've gotten from the headlines that they've been exposed to. And when they actually get their own experience, and if it's a reasonable system, if it satisfies their needs, they very quickly, people are reasonable and they come to reasonable conclusions, and society responds in reasonable ways to these things. That's my experience, and that's my expectation.
Awesome. Well, I think that's honestly a perfect way to end the conversation. James, thank you so much, man. Thank you so much.
Thanks for having me.
2 hours of my brain being filled with an incredible amount of knowledge, and I can't wait to process it for the next 5 years. Honestly, man, it's such an amazing conversation. Thank you, Hans and Ishan, for being part of the panel. Thank you, everybody in the comments who have taken part of the discussion. James, I'll give you the last words. Anything you want to share with the stream, and if any last parting thoughts from your side?
Thanks for having me. It's super useful to me to get questions and have to think about answers. It makes me understand the thing better myself.
That's awesome. I'm glad we were able to offer that. You're obviously welcome anytime, James. If you ever want to come back on, you're more than welcome to. And yeah, thank you, everybody. We're going to sign off. We're going to end the broadcast. Thank you so much. Seriously, thank you for your support, everybody.
Nice to meet you all.
All right. And